Good afternoon, everybody. Welcome on the PEROSH webinar on artificial insights. Sorry for the delay. We have a bit of a late start because we tried to restore the connection with two of our speakers, and we were successful. So we have all four speakers on board now in our webinar. This is a webinar from PEROSH, the Partnership on European Research in Occupational Safety and Health. Maybe some of you are familiar with our webinars. We have a YouTube feed where you can have a look at earlier webinars. And also this webinar will be recorded and posted on our YouTube feed, and you can also access the YouTube feed through our website. I would sincerely invite you to visit our website where after a while a pop-up will appear where you can subscribe to our newsletter and events. Please do, because then in the future you will receive invitations for these sort of webinars. Okay, now we have four speakers, and I would like to introduce the first speaker to you. He is from our Polish member institute. His name is Andrzej Grabowski. He is a professor, head of the virtual reality laboratory in the Polish Institute, which is based in Warsaw. And he is a real expert, as you may have learned from his small biography in virtual reality, augmented reality, and artificial intelligence. Now, Andrzej will share with us findings from a European project in the construction sector where they worked with mobile robots, which were also programmed through artificial intelligence. I hope we can get Andrzej on board with his presentation. So if we could see Andrzej now, then perhaps he switched on the camera. Not yet. Can you please switch on your camera, Andrzej, and your mic, of course, and then we can listen to your presentation. Trying to get Andrzej in the meeting. Yes, but hij zegt dat hij daar geen toestemming voor heeft. I do not have permission to do that. We are trying to find Andrzej Grabowski. In principle, you should be able to switch on your camera and your mic. Can you now try it, Andrzej?
Okay, the camera should working now, and I can share this screen.
Thank you. Welcome, Andrzej.
Do you hear me well and see the screen? Because there was some technical difficulties.
Yes, everything is okay now. Yeah. Thanks.
Okay. Thank you. Sorry for the delay, and thank you very much for the introduction. I'm Andrzej Grabowski, and today I'm going to speak a little bit about artificial intelligence-powered robot at a construction site. We all are used to robots in industry, in factories, because robots are designed to perform tasks that are dangerous, repetitive, or require high precision. But nowadays, the robots are coming out from the factories to the different environments like construction sites. The robots have a lot of advantages, but they also possess new threats. For example, it is difficult to keep people safe in the case of collaborative robots comparing to the remotely controlled robots, because the semi-autonomous or full autonomous robots are governed by artificial intelligence algorithms, and it's quite difficult to develop them. This is especially dangerous at the construction site, because such robots must have a lot of power, for example, to move heavy objects or use tools like high power drills. In such situation, it is useful to use virtual reality to test new hardware, to test new software, to test new solutions, artificial intelligence algorithm in safe simulated environment. And after such simulation, the real robot was developed, and this mobile robot, collaborative robot, was developed to perform following tasks like collaborative transport, supervised drilling, supervised spraying of insulation, and collaborative assembly of formwork. And during the testing phase of this robot, all our potential applications were thoroughly tested at the actual construction site. It was a military hospital in Krakow, in Poland, and the robot was tested by the end users. I mean, actual construction workers. And to investigate the assessment of this robot, especially in the scope of the occupational health and safe, accessibility, and usability, we developed a simple tool, a questionnaire tool with following subsections like acceptability, adaptability, efficiency, satisfaction, safety, dependability, ease of use, and anxiety. And we have two groups, workers working with the robots, and construction workers who didn't work with the robot, but they could see movies how the robot works. And as we see, and as we see, the assessment of the robot is higher in the case of people who have actual experience with this robot. For a deeper understanding of the assessment of the robot, it's important also to compare not only the average value, but also to analyze all subscales. And here the results are presented as a percentage of maximal possible value, and on the screen they are sorted from the highest to the lowest. So there are differences not only in the average ratings, as I said before, but also in the ranking of individual components. For example, people working with the cobot rated safety, accessibility, and dependability the highest. On the other hand, those not working with the robots rated satisfaction, accessibility, and usefulness the highest. It is interesting that anxiety in both groups is almost the same. We have 37 and 38%. It suggests that the robots, the real interaction with the robots, do not increase the anxiety level, and it's very good information from the point of view of the practical implementation of the robot. Considering the order of the list of the sorted components, the positive influence of getting an experience in cooperation with the robot is visible for the following components: safety, a shift from the fourth to the first place on the list, and dependability, a shift from sixth to the third place. It means that the people without the experience with the robot tend to think that such robots are not safe. But people with experience with the cooperation with the robot, they can see that it's quite safe device. The negative influence is visible for the satisfaction, a shift from the first place to the first place on the list, and efficiency, a shift from the third to the sixth place on the list. And efficiency, I think, is the most important problem from the technological point of view at the moment. Switching to the summary, operating mobile cobots in complex and dynamic environments poses significant challenges for human operators who need to adequate skills and knowledge to ensure safety and efficiency. Because the autonomous mobile robots are something quite new in our environment. So the interactive simulation and training can be very useful for the construction workers before they will use real robots on the construction site. And virtual reality simulation can be also used to evaluate the hardware, software, and artificial intelligence algorithm. The implementation of robots in construction environments contributes to enhance worker safety, particularly by minimizing exposure to hazardous substances like those related during installation application, and reducing mechanical risks associated with drilling, especially drilling and in sailings. Moreover, automatic monotonous high musculoskeletal load tasks, such as overhead drilling, leads to noticeable improvements in safety and comfort for construction workers. And construction workers involved in a hospital construction project in Poland rated the robots highly across various parameters, including safety. The robot achieved 81% of the maximum score. I think it's very, very high assessment. Accessibility 78%, dependability 73%, and satisfaction. And what's important, the anxiety level was very low, only 57%, which indicates also that there is a lack of job displacement concerns, reflecting positive acceptance of cobot integration at real construction sites. Thank you very much for your attention.
Thank you, Andrzej. Great project, this concept. I guess if people Google on this term, they probably will find. Can you please stop sharing, Andrzej, your camera?
Yes.
Yeah, thank you. If people start Googling on this term, concept project, probably they will still find the website of the project, I guess. And I forgot to say to all the participants that if you have a question, there is a Q&A part in this webinar. Please post it there or leave a message in the chat, whatever you prefer. But the Q&A part would be the best, really. And we have one remark in the chat, so let me have a look. Very interesting talk. This person would be interested to know more about the actual activities for which robots are deployed on construction sites. Can you say a few words on that, Andrzej? So, which actual activities, we saw a few pictures, are robots deployed in?
Yes, of course. In the project, we tested the robot, but it was in small scale. We used the robot, for example, for drilling tasks, to use high-power drill to make holes in the ceiling and in the walls. A collaborative transport And I think another important task is the insulation, because the insulation is in many cases toxic. So it's better to do it without the human around the harmful chemical substances. But of course, it's only a project, a European project, so we have to wait a few years to mass implementation. And at the moment, the drilling task is the most common in the case of the teleoperated robots, which are available on the market.
Yeah. Okay, thanks a lot, Andrzej. So that is great to hear that specifically harmful tasks or physically demanding tasks can be taken over by this robot in the construction sector. Thanks a lot, great. So please, if you have a question, post it in the chat or post it in the Q&A and we try to answer it. If we have not enough time to answer all the questions, leave your email address so I can invite the speakers to send you an answer later on. Okay, then we will move to our next speaker. His name is Colin Chambers. He's from the HSE, the Health and Safety Executive in the United Kingdom. HSE is a member of PEROSH. They also have a big research institute where they are doing a lot of testing and doing a lot of research. But HSE, as some of you might know, is also the regulator in the UK. It's the Labour Inspectorate. And of course, the Labour Inspectorate is keen to know in what sort of situations AI is being used nowadays in industry. So that is the reason why they have started a project to make an inventory of use cases of AI in several industries, companies in the UK. And Colin will say a few words on that. He is a member of the Risk and Analytics Group within the HSE Science Division. That is the division which is really a member of PEROSH, and he has a focus on high hazard industries. You can get in touch with Colin if you wish through his email address. The email address you can find in the program. And I would like to invite Colin to start sharing his screen and turn on his mic, turn on his camera, his mic, start sharing his screen to give his presentation. There we see Colin coming. Yes, thanks a lot, Colin. And if you can switch to full screen mode.
I just need to remove.
Yeah.
Just a minute.
Take your time. Yeah, that's the icon for full screen. Yeah, excellent. We have it now on full screen. So Colin, please share your story with us.
Okay. Good afternoon, everybody. My name is Dr. Colin Chambers. I work at the HSE's Science Division. And today I'll present work done by myself and my colleague, Freya Anderson, on developing an industrial health and safety AI use case database. This study maps AI applications in HSE regulated industries to provide strategic insights to inform HSE's future regulatory approach to AI. So the main objectives of this work were to document real-world AI use cases in HSE regulated industries, to identify potential AI related occupational health and safety risks, and to support HSE in developing its regulatory approach to the application of AI in industry. So, what did we do? Well, first of all, the scope of the work is a wide range of industries that HSE regulates, and these for small to medium enterprises, right through to major companies. And we just asked them a simple question. tell us how you use AI in your workplace. So to get this information, we had a two-stage approach. First of all, we spoke to our HSE staff who have contact with various industry stakeholders, and we asked them for knowledge of AI use cases that they were aware of. And then we performed an external engagement process, and we performed an anonymous survey using HSE media outlets and also using the LinkedIn platform. So we developed an AI classification scheme just for this purpose. And we wanted to identify the different types of of AI use case. We wanted to provide a wide range of useful information around different aspects of the AI use cases, which can be used within our organization. And as the data information gathering exercise progressed, we then further refined our classification scheme. So we gathered in total 270 responses to our AI use case. And after some post-processing, this was reduced to 247. We removed certain cases where respondents referred to what they thought would be useful things for AI to do, rather than what they actually had experience of within their workplace. So we were looking for, a number of insights. We were looking for detailed descriptions of the AI use case, so we could tell exactly what was being done and how it was being done. We were interested in the types of AI model used, for instance, generative AI, machine learning, and so on. We were interested in the prevalence of different types of AI. Some were only used on a small number of cases, and some were widely used. We were interested in which of the sectors that HSE regulates were where these types of AI use case were used. We were interested in the high-level health and safety risks. It is for later work in this project where we hope to look in more detail at this aspect, because that is our core work. We looked at the approaches, or we asked for information on the assurance approaches used by the different respondents, whether they used assurance frameworks and so on. And then we asked them for examples of specific assurance controls they use. And most of them referred to things like human in the loop and human validation of activities performed. So some examples of the actual AI use cases identified were where ChatGPT was used, for example, to perform a risk assessment and to outline safety procedures and safety documents. We note that the respondents were very quick to state that all the outputs from this were validated by relevant experts. There were a number of cases of computer vision that was used for object and worker detection and identification. We noted a number of uses in predictive maintenance where AI was used in fault detection and early warning of potential failures. AI was used in autonomous systems for control of cobots and mobile robots and so on. AI was also used for monitoring worker safety compliance, where the AI was used to analyze video feed and was able to detect whether workers were wearing the correct PPE, and was also able to detect if workers were too close to dangerous machinery or were in other high-risk situations. AI was also used for in the process industries for analysis and optimization of processes, and also to detect any anomalies within the process operation. And one that we didn't expect was that AI was used to automatically develop health and safety training material like videos and presentations and so on. So we've got this information. What are we going to do next? Well, we are going to carry on talking to a wide range of stakeholders. We have an internal artificial intelligence common interest group where all the stakeholders within HSE and some external stakeholders meet regularly to discuss matters of interest with regard to regulation of AI. We already have, and we're keen to establish relationships with relevant industry and academic stakeholders to share knowledge and learning about AI use cases, and for these stakeholders to tell us what problems they have and what solutions they have. And all of this will help us in developing our approach to regulation. We are also keeping abreast of new developments through horizon scanning activities, where the Health and Safety Executive has a horizon scanning function. And in general, we're building the capabilities and experience across all our technical specialists and scientific personnel as part of the work within HSE. So that's just given you a very brief outline of what we're looking at. So first of all, we have developed what we think is a reasonably robust AI use case classification scheme. We've produced an AI database of applications, which is accessible to colleagues across HSE, and it is intended that this will feed into our research and into our policy tasks within the organization. We've identified already a number of insights regarding AI applications, some of them surprising, some of them not so much. And we've sort of been able to recognize a number of emerging AI-related health and safety risks. And we're only just started to look at this in detail. And so we're going to put a lot more work into this area, because if we know what the health and safety risks are, then we can work with stakeholders and to help them to implement AI in a safe and useful way. So we intend in future to strengthen our regulatory approach to AI through ongoing data analysis and through a consistent and collaboration and discussions with stakeholders. And we have already said we want to build further our internal expertise, and as part of an enabling regulator, we want to encourage industry to use AI, And we certainly see across the UK and across Europe that there is already a strong uptake of AI, and it has many users. And so we need to keep abreast of all these and to be able to develop our knowledge and implications so that we can best help support occupational health and safety. Thank you.
Thanks a lot. Please stop sharing, Colin, if you are so kind.
Thank you.
Excellent. Thank you. That's great. I can imagine that the regulator wants to know how AI is being used. The best example you give is a risk assessment that has been produced by an AI tool. You give it to the inspector and you said, yeah, I fulfilled my task, that's it. And that's not how it works, of course. We have the same in the domain of researchers, which is PEROSH, where they are using more and more AI tools to do the stats, to do the overviews and the summaries. But we have protocols now telling researchers that you are responsible in the end for what you are writing down or for what you are publishing. The same with an employer, I can imagine, that you are responsible. So whatever way you produce a risk assessment product, you are responsible in the end for the quality of it. I see no questions, Colin. There is still a question for Andrzej, but perhaps we will answer this a bit later because we are a bit behind on schedule. There is one remark in the chat. Good afternoon, Colin and all the team in France. The accreditation body, COFRAC, has done a great work with National Metrology Laboratories AI experts to develop an accreditation scheme. Do you foresee HSE guidance, such as these sort of documents, for the users, benefits and pitfalls of AI?
I think HSE likes to work with collaborators and likes to work with stakeholder organizations. And it is a common model for HSE to produce joint guidance, because HSE is very interested that their guidance is relevant to industry and would therefore be much more likely to be adopted. So HSE will certainly be involved with guidance, but HSE actively encourages other organizations to work with us to produce joint guidance in different topic areas.
Okay. And if people would go to the HSE website, Colin, would they find already some docs, some guidance on AI, the risks and the use, or is this still in preparation?
It's still in preparation. It's early stages. They will find links to the UK government's approach to regulating AI, and HSE is working strongly to make sure that all the work we produce conforms with that guidance, so that industry knows it can expect a consistent message across all sectors.
Yeah, okay. Thank you very much, Colin. We will go to our next speaker. We are a bit behind schedule, so we will try to speed up a bit, but still allowing the next speaker from Germany to share his experiences with us. His name is Kevin Seeser-Reich. He works at the Institut für Arbeitsforschung in Germany, and he will say a few words on the Competence Center for AI and Big Data at IFA, this institute, which is also a member of PEROSH, by the way. And I'm really keen to learn about it. I saw already on their website a dedicated webpage to this Competence Center of AI. So I would invite everybody to have a look there. And Kevin, please, if you can start sharing your screen, your camera. Yeah, we see your presentation. If you can make it full screen mode, that would be great. Yeah, fantastic. And
yes, can you hear me?
You can start, Kevin.
Perfect. Thank you for the introduction. I'm Kevin Seeser-Reich and I work at the Institute for Occupational Safety and Health. And today I'm going to give you a quick introductory look at the Competence Center for Artificial Intelligence and Big Data at the IFA, and then look at our current research in the area of near fall detection. The Competence Center for AI and Big Data tries to bundle our artificial intelligence experience at the IFA because we have many sub-departments, and our sub-department is more focused on applied research of artificial intelligence, while we have colleagues that are experts in the area of standardization. They contribute to national and international committees to find guidelines at what point is an AI considered to be safe, what kind of criteria have to be fulfilled, how can we check these criteria. So they are experts in these areas, while our sub-department is doing applied research. Besides that, we also have students in a dual study program that we are supervising. We are offering bachelor and master's theses, and we are of course also publishing our research results as research papers. Besides that, we're also doing public relations work. So we are educating the public about the AI projects that we are doing, but also a bit more in general, what is AI? What is AI used for in the industry at the moment? For this, we're giving workshops, presentations, and writing online articles. And lastly, we are also coordinating events, committees, workshops, and doing networking. Now let's have a look at one of our research projects that I have brought here. It's about near fall detection in order to prevent real falls. Near fall detection can be used as a basis to prevent falls in the workplace. But of course, if you want to train artificial intelligence, you need data first. And the area of near fall detection has a rather limited number of data sets at the moment, so it's not really comparable to computer vision or natural language processing, where there are a large number of big and established data sets. Most public data sets that you can find for near fall or fall detection are mainly focused on older people, which makes sense because they are at high risk of falling, but it's not really applicable to the workplace. And often they have only single or low double-digit number of subjects. So the variety of data is quite limited. Therefore, we had to create our own data set. We used a motion capturing suite for that. You will see that later in the presentation. After recording the raw sensory data, we also enriched the data with ergonomic metrics like the velocity of the center of mass or the acceleration of the center of mass. And currently, we are performing machine learning research. We are trying to figure out which models are performing well and how can they be used in the future. There are multiple ways how we can go about then actually preventing real falls once we are able to detect near falls. And that is, for example, via forecasting. So when we are able to detect near falls, it could be used to forecast real falls happening and then preventing them, or at least limiting the impact of the real fall and the damage that is being done by that. Or using it to monitor workers doing their everyday work and then trying to find patterns in the data, like maybe always in the last half hour during certain activities, near falls are just occurring more often. Or there are certain areas like a floor that is especially cluttered, or maybe the floor has become too slippery, and this could then be detected there as well. And then you can use traditional fall prevention methods again in these areas to prevent further harm. What you can see here is the motion capturing suite that we used to record our data set. It's an Xsense Link motion capturing suite. It has 17 IMUs, and it covers the range of the human body quite well, as you can see on the right-hand side. We constructed a slip, trip, and misstep parkour about 17 meters long. The subjects were about 50 meters long, sorry. The subjects were told to walk across the parkour in a, for them, comfortable pace, and then at a pace that's a bit faster than comfortable for them. And then there were different numbers of traps that could be activated. And the subject didn't know at what cycle while walking through the parkour and at what place the trap is activated, so as for them not to anticipate any kind of trap and then be already kind of tense beforehand, so that the data that we actually recorded is as natural as possible. There are a number of data sets where falling is more simulated, which is a problem because simulating falls are not the same as real falls. The definition of a real fall is that it has to be involuntary, and the same goes for near falls. Here you can see a subject walking across the parkour. They are, of course, secured on a safety railing overhead, so that if they should actually fall, that nothing happens to them. Here you can see an example for a trip trap that is going to be activated. The subject is walking on a normal pace on the left-hand side and on a bit faster pace on the right-hand side. And during the mid of the swing of the leg, the part of the trap is going to snap up and then trip the subject. For our sliding traps, when the subject steps onto the trap, the panel is going to slide, and so there's just no friction, and this will induce a slip in our subjects. And for the last kind of trap that we had, once the subject steps onto the trap is going to give and induce a misstep. You could already see the misstep is a bit harder to detect because it's not as severe as a trip. The trip traps were definitely the most severe ones, which we could then also later see in our data analysis. You will see that on the last slide. Overall, we had 110 subjects. Half of them came from HKM, so they were steel workers, and the other half from DHL. They were post-delivery service workers, and we recorded 1,650 about trials of slips, trips, and missteps, and quite larger amount of baseline walking. But for the sake of class balance, we reduced it to about 50%, so also 1,650 trials of baseline walking for the data set. And this is actually also the largest, or the data set with the largest number of subjects for near falls that is currently published and available. And we just a few months ago published a paper about the creation of the data set in Sensors. Afterwards, we started with machine learning, and the first step was simply classifying whether a trial is a misstep, a slip, a trip, or just baseline walking. First, we used a decision tree classifier, but quickly figured out while tripping is quite distinct and easy to detect, it's way harder to differentiate between baseline walking, slipping and sliding, slipping and misstepping. And this might just be not a problem that is really able to be solved with a linear classifier. We performed a linear discriminant analysis. You can see the result here on the right-hand side. There you can see one cluster that is more apart from the other three clusters. This is the tripping cluster, and then we have slipping, misstepping, and baseline walking here. And you can already see the data is so closely clustered together that it's just difficult to separate them linearly. And the same goes for correlation analysis that also supports this theory that a linear classifier might just not be able to solve the problem. Therefore, we next took a look at neural networks, and we performed a neural architecture search with neural networks that are well suited to work with time series data. We looked into deep-conv LSTMs, CNNs, ResNets, and inception time networks, and got quite good performances, up to 99% accuracy. But to be fair, these were initial experiments that we did where we had kind of training wheels. So we told the network what kind of what part in the time series to look at, not what happened there, but just, okay, here happened something interesting, and then the performance was really good. When we took off the training wheels, the performance dropped a bit, to be fair. So by about up to 6 to 9% drop of performance when removing the indication where the STF event happened. Yeah, that's what we are currently doing and researching. We are in parallel writing a paper about our results, and the next step is going to be to reduce the number of sensors that is that the subject is wearing, because if we want to actually outfit workers during their workday, we can't just put them into 17 IMUs. That's just, I think it takes about 10 minutes if you are trained. We took more than 20 minutes to outfit one subject with the entire motion capturing suit. So figuring out with how little sensors we can get away in the end and still achieve acceptable performance in accuracy. Yeah, that's the next step in our research. Thank you for your attention, and that's it with my presentation.
Thank you, Kevin, for this very interesting research that is being done in Germany. We have a few questions. It is too much to answer them all now. There is one remark, Kevin, also directed to you in the chat. Please have a look. Maybe you can respond on it or take notice. I will have a look at a few remaining questions in the Q&A. Someone nicely indicated us that you do not look only at the chat, but also the Q&A, which is correct. So also the speakers, Colin already was answering some of those questions online. Please do this. The same to you, Andrzej. That would be great. There was also a question on the cobots in the construction sector. And at the end of the next presentation, I will see if any questions have been left that we should try to answer. If you really insist of receiving an answer, please leave your email address. And one of you did, and then later the speaker can answer your question by email. Kevin, thanks a lot again. A lot is taking place in Germany when it comes to AI, also with this competence center. That is really excellent. And we will go to our last speaker from France, and his name is Michaël Sarrey from the French Institute, INRS, also a member of PEROSH, and he will say a few words on the impact of AI in machine control systems. I would like to invite Michaël to join us to see if he can switch on his camera, share his screen, turn on his mic, and then we can...
Okay, do you hear me?
Yeah, we can hear you, Michaël. Thanks a lot.
Can you allow me to share my screen?
Yes, we can see you. And if you share your screen...
I can't.
Then you can...
Me?
I think if you share your screen, you can also share your presentation.
You can't?
One moment, please.
Yeah.
Now you can share your screen, Michaël.
Yeah.
It should work now.
Okay.
Excellent. We see it, full screen mode. Fantastic. And the floor is yours.
Okay, thank you. So, before we start this forward, until the end of 2022, the revision of the European Machinery Directive was in progress. In the meantime, research had been carried out into AI in machines. This research focused on machine learning technology, contributed to the work on the new regulation. This machinery regulation, EU 2023-1230, will be effective in 2027. I will present today the results of a study conducted at the INRS related to the AI in the machines. During this period, generative AI like GPT had not, to our knowledge, been integrated into machine control system. First of all, some definitions. In the field of automated machines, AI is a technology that allows machines to learn how to perform tasks by providing them examples. Instead of writing specific program, we create a learning environment where the machine can learn from the data we feed it. This approach eliminates the need for written programs but requires a large dataset representative of the task we want the machine to perform. A machine control system is a programmed electronic system that allows the machine to perform sequential or combinatorial actions. The machine control system is made of two parts. The functional part for the control system, which allows the machines to perform the tasks for which it is intended, and the safety-related part of the control system, SRPCS, which reduces as much as possible the risk of injury generated by the machine. The SRPCS is designed to have a level of reliability in accordance with the level of risk identified during the risk assessment, and is capable of safely and quickly stopping the machine when required. Let's take an example to understand the specifics of a control system with integrated AI. Imagine that we need to sort pieces of wood by species. To perform this task by hand, we would try to learn the characteristic of each species of wood. Then we would create a model. To automate this task without AI, we would do the same, program rules to distinguish these species of wood. However, with AI, there is no need to program rules. The AI will do it itself. This is what we call the learn automation. The system is not programmed to perform a task, but to learn how to perform a task. In this example, we have created a handling line to sort 4 types of wooden parts: ash, beech, oak, and cherry. Firstly, we create a database by rotating the parts under a camera in the manner of the canard marseillais. We proceed species by species in order to label the images a priori. This is the first specific feature of this type of machine, the need to create a learning database. In this example, the machine learns the oak class. Then the system is trained. In training mode, the machine creates its own program from this database. Once the training is completed, a classification can be launched. The handling line will put each piece of wood in the corresponding box. To do so, the AI provides the class of the pieces of wood. With this class, the system also gives the probability of correct results. In this example, 12 pieces of oak are presented to the AI, and the probability of a correct answer, oak, varies from 50 to 95%. However, 1 piece of oak has been classified as cherry, and with a probability of 67%. Indeed, the AI doesn't recognize its mistakes. So it's impossible to use this probability as a confidence factor in the AI's outcome. But this is the only evaluation available. If this classification was used to implement an SRPCS, it would be impossible to determine its reliability and its diagnostic coverage. So, currently, this is therefore impossible to use AI in the safety-related part of the control system. Previous results can be visualized in the confusion matrix. This table allows us to evaluate the result for the whole batch a posteriori, but gives us no information on the decision-making process. Machine learning is based on numerical function. In principle, each step of the calculation is transparent and can be rerun. However, the most advanced machine learning algorithm, like the deep learning, use millions of parameters in its neural network. Because of this number of parameters, the result becomes unexplainable. This is the second specific feature of this system. The problems of the unexplainability makes it difficult to train the model and hides possible biases in the database. The third specific feature is the determinism. The determinism is the ability of the system to produce the same result when submitted to the same solicitations. The following photos show the input for the same pieces of oak shot at the same place and in the same environmental conditions. This is the same object, but for the computer vision software, it's 8 different data. Even if these differences are minimal, they can have an impact on the result. That's why the AI system is not deterministic. As I mentioned at the beginning of my presentation, the study presented above was carried out during the revision of the Machinery Directive. The new machinery regulation anticipates the use of AI in machine control systems. However, explainability and determinism remains technical locks. An AI system cannot be used in SRPCS until these locks are released. When this is the case, the machine regulation defines a few obligations regarding the use of AI. The main recommendation concerns the action limits of the AI functions. The AI's action limits must remain within the bounds defined by the manufacturer in the risk assessment. This applies for the entire life of the machine, regardless of how it evolves. As a conclusion, we have seen the specific feature of a machine learning and its limit to be part of the safety-related control system. Nevertheless, the new machinery regulation anticipates the use of AI in SRPCS. So we will keep focusing on the technological evolutions such as generative AI and probably more to come. Thank you for your attention.
Thank you, Michaël, for your presentation. Really interesting. As all the presentations were, I saw some clapping hands, which indicates that people are happy with your presentation. So thanks a lot. We are at the end of our webinar. We are a bit late. We also started a bit late, so I take the opportunity to ask everybody maybe to stay on board a few minutes more, and I would like to invite all speakers to switch on their cameras. Just in case there are still some questions left for you guys. And I think a few questions are still there. I will run through them. And I saw that Colin especially already was answering some of the questions and remarks. And after that, we can close our webinar. So I think one question that remained unanswered, I think it was from Greece, is probably directed to you, Andrzej, when it comes to the cobots in the construction sector. The question is, thank you for the presentation on this cobot. Andrzej, I hope you are, yeah, I see you, you are still online. Could you elaborate, Andrzej, on the base for the safety assessment and validation that was used? For instance, the safety norms that were used for this cobot. Were any norms used?
Oh, first of all, I have to mention that this safety parameter, which was shown in the presentation, it's not a result of risk analysis. It was a perceived safety because we use questionnaire study. And switching to the certification, of course, in the research project, the robot was not certified because it was it's not mandatory. So we don't have a certification of the robot. And in this project, we didn't perform the full risk analysis. We have performed the hazard analysis, and we have a quite long list of the hazards on the construction site. And the list of standards and norms for the robots is quite long. Of course, the machine directive is a starting point, but we have also a standard for industrial robots. We have a standard for collaborative robots, and we have also standards for driverless autonomous vehicles, for example, trucks. And we had used them all in our analysis.
Okay. Thanks a lot, Andrzej. That's really interesting. I'm looking at some other questions. I think most of them in the Q&A we have answered. And I replied to one person who had a question. Please leave an email address, and then Colin will respond to your remark. Thank you for the interesting presentations. I see here a question to Colin. Did you encounter examples of AI applications coming close to unacceptable or high-risk categorization within the IA Act related to emotion recognition? Colin?
Yes. Shall we say that there were one or two descriptions of the use of AI?
For stress management, that was the example, for instance. Yeah.
Yes, that looked at fatigue, and in particular fatigue for drivers. And there were one or two examples of this, and I'm not sure what executive action it performed other than to inform the driver that these things had been detected, and also we're not clear about what the company did with this information, but certainly that was an example.
Okay, excellent. Thank you. Thank you. Mm-hmm. Then another question from a professional who was wondering, and this is a question to any of the speakers who is willing to respond. We have to use integrated generative AI, yeah? Or should we decouple it, because we are not the programmers and we don't have any knowledge of coding. I mean, what should we do? What I understand from this question is, should we accept it or should we just avoid its use of AI? Could someone respond to that, one of the speakers?
I think from my point of view and from looking at the responses, I mean, the survey was anonymous, but there was information given us with examples, for instance, where a respondent would say, I use it for, and they would tell us what they used it for. My boss doesn't know that I use it for this, but it's improved my productivity, so I'm going to keep using it. And I think what that tells us is that no matter what we think about the use of AI, it's here to stay. And that's why we should be more looking at how we can contribute towards the assurance of AI and towards approaches and techniques that help to build trust in AI. And so if people are going to use it, hopefully the problems it can cause won't be too many.
Yeah. Okay, thank you. I think those are excellent, I would say, closing words when it comes to AI use in our field of work, in research, in occupational safety and health. AI is here to stay, indeed, and we should deal with it somehow. And a webinar like this helps to get an overview horizon scanning of AI use in some of the PEROSH research institutes. I would like to thank all speakers again for your wonderful contributions. I would like to thank all attendants. We had 120 people participating in this webinar for their time invested. Thank you for the questions. We will check the transcript of all the questions carefully to see if anything has been left unanswered. We were able, with the technical team, to solve quite some challenges. Two speakers were difficult to get access to the webinar. My mic was gone wrong, and then all of a sudden they said, "Ja, Michaël, don't forget it's Friday the 13th." And I think they are completely right. Anyway, we survived. And again, thanks a lot to everybody. The video will be published soon, and all people who registered for the webinar will receive a link, a message to this video to have a look at this webinar. Thanks a lot. I wish you a nice weekend, nice evening, and hope to see you again soon, probably next year in one of our PEROSH webinars. Thanks a lot.